चलिए दोस्तों शुरू करते हैं without wasting a time. In this video, we'll talk about the migration from LDP to segment routing, how we can do the migration from the LDP to segment routing. So there on the high level, 6 steps are involved. What are the steps? Are first step we can enable the segment routing in the core, and once we have to enable the segment routing in the core, we need to plan two things. First is the SRGB block. What is the segment routing global block size will be? And second thing, we need to plan for the NODE SID and Prefix-SID values. How we'll calculate what the number will be from that range. Once we're done with the segment routing enabling the core in the provider router P1, P2, P3, P4, we can say this is the we can say let's say this is our core. Okay. Once we enable the segment route in the core, after that we can enable the TILFA. TILFA will help us in case of link failure and node failure detection, node failure, correct? This will install the backup path and all the stuff actually. For this enablement of the segment around the core, which involve two steps configuration. First is the SRGB block, and second step is the assignment of prefixed on the loopbacks. We will do this configuration with the help of Ansible Playbook. With the help of automation, we use the Ansible Playbooks. Segment routing the core node and covering the second step enabling the TILFA, we can move with the third step where we have to take care about the LDP and SR internet, because once we enable the segment on the core routers, so on the provider is the router still running on the LDP only, so we need to do the internet working. How we'll achieve the internet working? As we have covered in the last video, with the help of mapping server and mapping client, we can do the internet working between LDP node and SR nodes. So mapping server basically advertise the SID for the LDP nodes, and mapping client with the router, border router, which have a one leg in the LDP and one leg in the SR enabled node. So this will exchange the label for them. Once we done that, we can remove the LDP from the core link by link basis, and after that we will configure the segment routing on the edge router, provide the edge router. On this router also we need to plan two things again, same thing, SRGB block and prefix-SID and node SID. Once we done the config with the edge router also, uh, again we have to remove the protocol, or we give the preference to the segment routing. So we can again disable the LDP link by link basis, or we can change the preference in the ISS process or IGP process for the LDP to SR prefer. So these are the steps involved from the high level perspective, how we can plan the migration from LDP to segment routing. There are multiple other aspects we need might be required, that will be based on the network. What are the devices? What are the software images running on those devices? So we need to take care about that. So let's jump to the Ansible playbook. In this video, basically main thing we'll cover how we can push the configuration of SRGB block and prefix-SID on this core and edge router with the help of Ansible playbook. And as you can see that I have mentioned the SID for each router. So how I calculate this value? We are using the SRG block 16,000 to 17,000. So I have calculated the prefix-SID and node SID. SRGB block starting at 16,000 plus loopback IP 4 octet. Like for example, P1 loopback IP is 1.1.1.1. So fourth octet is 1 plus 16,000. So prefix-SID will be 16,001. Same way, like for the P3 router, we have in a loopback is 33.33.33.33. So fourth octet of the loopback IP will be 33. So 16,000 plus 33. So prefix-SID for this device, this router will be 16,033. Similar here, we have a loopback 0 IP is 44.44.44.44. So we have a prefix is 16,044. So in this topology, we have two type of devices like iosxr and iosxc devices. So I have created a two Ansible playbook, one for the iosxr, one for iosxc. Let's jump to the Ansible playbooks. So let's quickly go through the Ansible playbooks, which will help us in the configuring the sRGB block and prefix it. The directory for the migration I have prepared. In this directory, we have four files. Two files are for the iosxr and two files for the iosxc. So let's start with this playbook, first playbook. Let me open this. playbook we have. So in this first task, you're doing the config segment routing. So these are the host iosxr. This is the group, you can say this is the group for the iosxr. In this I have covered all of the devices with the part of our topology. I will show in the inventory file, the Ansible inventory file. So we have these are the tasks in this playbook. First task is configure SRGB block. So this is using the iosxr config module. In this iosxr config, this line will be committed to the or configured on the device on the iosxr. And second task is, in this task we are enabling segment routing in the ISS core. So in the IGP protocol we are enabling this segment routing mpls. So this is the parent line, and under the router ISS core process we need to put these two lines, segment routing mpls, under that disk family IP for unicast. In the third task we are getting the output. We are getting the show run of the loopback, and after that we are splitting and breaking this and getting the fourth octet of the loopback, and that loopback fourth octet we are saving in this variable register output, and that fourth octet value, from this fourth octet value will calculate our prefix-SID or NODE SID. Like in this task we are configuring prefix-SID or NODE SID in the loopback 0 interface. So again we are using the iosxr config module. What we are doing in line interface loopback 0 address family going, and then prefix-SID index, and this variable is putting here. In this variable you get the first, we get the loopback IP. Then the loopback IP address we have broken into four pieces. Last octet we get the value, and last octet we are putting as a prefix-SID index, and then fourth octet. So this will be the prefix-SID for that device. Again this is going to the router ISS core process. After that we are checking the what are the changes are done on these devices. So let's quickly run this playbook. Ansible dash playbook LDP. This will do the config on the iosxr device. Let me do the verbose also. So we have done the configuration on the P1, P2, P3. Let's see what are the changes is done. So this is the P3 router. Okay, on the standard outlines we can see that what are the things we have done. Router ISS core process, we have enabled the segment routing MPLS first thing. And second thing, we have done the on the interface loopback 0, we have done this prefix-SID index we have configured. And similar way we see the P1 we have configured the SRGB block, and this under the ISS route core process we have enabled the segment routing, and we have configured the prefix. And similar way for this P2 device, for P2 node also we have done this configuration. In same way for the PE2 provider is 2 router also, we have done the ISI segment routing process, SRGB block and prefix-SID. Let's go to now our another playbook, that is iosxr. Clear the screen and in the first playbook we have done the segment routing prefix-SID, SRGB block and segment routing enable in the ISS process for the iosxr device. Now we are doing for the iosxr. So this is the iosxr playbook. So again in this playbook also we have a three tasks. Task number one is to define the SRGB block, and in the task two we are getting the show run of the loopback, and from that we are getting the fourth octet value, and that value we are putting in the using in the index command while we configuring the prefix-SID and NODE SID. Let's run this playbook also. Ansible playbook. This is iosxr. Step one. Again, let me do the verbose. So we have done the changes. So we have in this provider one router. This is the XC device. On this device, these are the update is done. Under the segment routing mpls, in the connected prefix-SID maps, we have assigned the prefix-SID. This in on the P4 also we have done this configuration updates. Okay. In similar way, here in the first task, we have configured the sRGB block on this P4 node, and similar on the P1 node also we have configured the. So in the first part of playbook, we have enabled the segment routing configuration and for cover two step sRGB step block step and second thing prefix-SID. In the second part of the playbook, we are changing the preference. We are giving the preference to the segment routing over LDP. So let's same way we have in a two playbook, one for the iosxr devices, one for the iosxc device. Let me show you the SR prefer iosxr playbook. So this is the iosxr playbook. In this again we have two tasks. In the first task we are doing this SR prefer. This is the way in the router ISS core process. In the address family you have to run the segment routing mpls prefer. So this way segment routing is the preference over LTP. In the second task, we are checking the mpls forwarding. So we'll get to know about the prefix-SIDs or NODE SID in the, or we can say what are the urgency SID and prefix-SID in the mpls forwarding table. And here we are again defining the host. So let me show the inventory also. Slash etc ansible in the inventory file. Here we have divided the boxes. iosxr, we have a four router P1, P2, P2, P3. So these are the devices are the iosxr. For this device, here are the variable. Here the credential configure, username, password. Similar way, iosxc device, we have two iosxc device in the topology, and these are the IP and these are the variable defined. Let's run the playbook. Simple that playbook SR prefer iosxr. So the four devices for the iosxr. We have a P2, P3, P1, P2. Changes are done. In the house, in the second task, we are getting the place forwarding table. Correct. So these are the prefix-SID we can see in the output for the SR seed and agency seeds. These are the agency seed, and this is the prefix-SID. Go up. So here we have done the command. These are the command pushed on the devices. Route under the router ISS core process. Address from the IPv4 segment routing in place SR prefer for all of the four nodes we have pushed. Let's now push the configuration to. Let me open the iosxc. SR prefer iosxc. Here also. So this is the command line required to enable the SR label preferred on the iosxc device. We'll go to the first segment routing mpls under that set attribute under the address family. We need to put this command SR label preferred. In this is the inventory iosxc. We have a two host. Playbook. Okay, here we have done the changes in the iosxc box also, and these are the updates and segment routing mpls set attributes. This is for the P4 and this update is for P1. Let's jump to the device. We'll verify the two device configuration. One is the iosxc and one is the XR. So here we are on the P1 node. Let's verify configuration here on the router. Show run segment routing mpls. So this is the SRGB block we have pushed via the Ansible Playbook. The router ISS. Let's verify. This is the router ISS core process. Here we have pushed the segment routing mpls SR prefer, and here we configure the prefix-SID. So we have an entry for the prefix-SID, emergency SID and prefixing the mpls forwarding. So this is the iosxr device. Let's do the same verification on the one of the iosxr box. So here we are on the iosxr device. Let's do the verification here also. Show run. Where it is segment routing mpls. We have given the preference over LDP to the segment routing. Here is the SRGB block, and here is in the connected prefix-SID map we have given the index. So we can see that with the help of Ansible Playbook or automation, we have pulled the